Hello students, we will practice questions about HCF and LCM today. Now questions regarding this topic are very frequent in exams. Every year about 1 to 2 questions are based on the topic HCF and LCM. So without further ado, let's begin with question number 1. Question number 1 states that two numbers are in the ratio of 3:5 and their LCM is 1500. So we need to figure out what the HCF is. Now let the two numbers be 3x and 5x because they are in the ratio of what? 3:5. Hence the HCF is x using the formula, right? And the LCM is going to be what? So if I say that what is HCF, HCF is going to be nothing but x, correct? Whereas LCM is going to be what? LCM is going to be 3 times 5 times x, and this is nothing but this is 15x. Now it is given that LCM is what? 1500. So this 1500 is equal to what? 15x. So if I'm going to equate 1500 with 15x, I will get what? X equals to 100. So x is nothing but x is 100. So the HCF is what? HCF is 100. That is option number A. Let's move on to next question. Next question states that find the smallest number that leaves a remainder what? 4 on division by what? 5, and 5 on division of what? 6, and 6 on division by what? 7, and 7 on division by 8, and further 8 on division by 9. So I need to find the smallest number that does this. So let's figure out what the number is. Now when a number is divided by 8, a remainder of 7 can be thought of as a remainder of -1. This idea is very useful in a bunch of questions. And when a number is divided by 8, just remember what did I say? That a remainder of 7 can be thought as what? A remainder of -1. So according to this, can I say that n equals to 5a minus 1, or I can write what? N plus 1 equals to what? 5, correct? Now similarly, I can write then n equals to 6b minus 1, or I can write that n plus 1 equals to what? 6 times b. Similarly, I can write that n equals to 7c minus 1, or n plus 1 equals to 7c. Then n equals to 8d minus 1, or n plus 1 equals to 8d. And lastly, n equals to 9e minus 1, or n plus 1 equals to what? 9e. Now n plus 1 can be expressed as what? It can be expressed as a multiple of 5, as a multiple of 6, as a multiple of 7, 8 and also 9. So can I write, just a second, okay, so can I write that n plus 1 is nothing but it is 5a into 6b into 7c into 8d into 9e, alright? Or I can say that n is nothing but n is this whole number, that is 5a into 6b into 7c into 8d into 9e minus 1. Now the smallest value of n will be when we find the smallest common multiple of what? 5, 6, 7, 8 and 9. Or I can say that LCM of 5, 6, 7, 8 and 9. Now LCM of 5, 6, 7, 8, 9 minus 1 is going to be what? So if I'm going to find the LCM is going to be 2, 5, 2, 0, and then we have -1, so -1, and this is going to be what? 2, 5, 1, 9. Now the question is that we need to find the smallest number that leaves a remainder of 4 on division of 5, 5 on division of 6, 6 on division of 7 and 7 on division by 8. and 8 on division by what? 9. Hence the value is going to be what? 2519. So it's going to be option number A, that is 2519. Let's move on to the third question and let's see what the third question states. So the third question states that how many pairs of positive integers x and y exist such that the HCF of x and y is 35 and sum of x and y is what? 1085. Now if we take away the HCF from two numbers, the pair of numbers we are left with have to be what? Co-prime. This is a fabulous starting point for a number of questions, okay? So let HCF of x and y be h. So if I talk about HCF, so let the HCF of x and y be what? H, okay? Then we can write that x is nothing but x is h times a and y is nothing but y is what? H times b. Furthermore, note that HCF of a and b has to be 1. So HCF of a comma b has to be equal to 1. This is one of the most important property. One that seems obvious when it is mentioned, but a property a number of people overlook. So we can write that x is nothing but x is 35a and y is nothing but y is 35b. So this is nothing but this is 35a and this is nothing but this is 35b. So x plus y is what? 1085. Okay. So this is what? This is 35 times a plus b because x was what? 35a and y was what? 35b. So 35 is common. So if I'm going to add x and y, it will be 35a plus b. And this is nothing but this is equal to 1085. That is a plus b is nothing but a plus b is what? 31. Now we need to find a pair of co-prime integers that add up to what? That add up to a number 31. Another way of looking at it is to find out the integers which are less than 31. Those are co-prime and the sum is going to be what? 31, as we have mentioned earlier. Now, the thing is that since 31 is prime, all the pair integers that add up to 31 will be co-prime to each other. Or there are totally what? 15 pairs that satisfy this condition. So the answer is going to be what? Answer is going to be 15. I hope you understood this. So let's move on to question number 4. Now what does question number 4 states? Question number 4 states that LCM of two natural numbers, that is p and q, where p is greater than q is what? 935. So what is the maximum possible sum of digits of q? Now we know what? We know that 935 is nothing but it is 5 into 11 into 17. And let p equals to h of x and q equals to h of y. Where h is what? Where h is the HCF of p and q. Therefore, LCM of p and q is going to be what? LCM is going to be hxy. Okay, so this is going to be LCM and h is what? H is nothing but HCF. Now the thing is that we have LCM equals to 935. That is hxy is nothing but hx is 935. Now if h is 1 and p is 935 and q is 1, then the sum of digits of q is also 1. Okay, that is what I am trying to say is, that if h is 1, alright, then p is going to be what? 935 and q is what? Q is 1, whereas the sum of digits, so the sum of digits, if I write capital S for the sum of digits of q, then that has to be 1. Similarly, when h equals to 5 and p is nothing but 5 into 17, so this has to be what? 85, whereas q is what? Q is 5 into 11, that is what? 55. So the sum is going to be, sum of digits of q is going to be what? 10. Similarly, if h is nothing but h is 11 and p is nothing, p is 11 into 17, then this is going to be what? 187. And then q is going to be what? Q is going to be 11 into 5, that is 55. 5. So this is what 55, and sum of digits is going to be what? Q, that is sum of digits of Q is going to be what? 10. Similarly, I'm going to write other stuff again because we need to calculate for h equals to 17 as well. So for that, let me just erase. Alright. So now if h is equals to 17, so if h is equals to 17 and p is nothing but p is 17 times 11, that is 187, and q is nothing, q is 17 into 5, that is 85. So the sum of the digits of q is going to be what? 13. Now the HCF can be combined of 17, 11 and 5, correct? So if I'm going to combine the HCF, then h is nothing but 5 times 11. So p is going to be nothing but 5 into 11 into 17. So p is going to be what? 935. And q is going to be what? 5 times 11, that is 55. So the sum of digits of q is going to be what? 10. Now, if h is nothing but h is 5 into 17 and q is what? Q is 5 into 17 into 11, that is 935. So q is going to be what? 5 times 17, that is 85, and sum of digits of q is going to be what? Again 30. Now if h is going to be what? 11 times 17, we need to write that down as well. Okay, so if h is going to be what? 11 times 17, and p is going to be 11 into 17 into 5, that is 935, and q is nothing but 11 into 17, that is 187. Then the sum of digits is going to be what? Sum of digits is going to be of q is going to be what? 16. So the maximum possible sum of digits is going to be what? It's going to be 16. So q is going to be what? 16. There is no such option, so let's make one. So option number E is 16. So the correct answer is what? 16. Let's move on to next question, that is question number 5. So question number 5 states that 6 different sweet varieties of count 32, 216, 136, 88, 184 and 120 were offered for a particular occasion. And they need to be packed in such a way that each box has the same variety of sweets and the number of sweets in each box is also the same. So what is the minimum number of boxes that are required to be packed? Now HCF and divide, like we basically have to find the HCF and then divide the total sweets by that. So all sweets need to be packed and each box has the same variety. This implies the number of sweets in each box should be what? HCF of different counts of sweets. That is what? That is HCF of what? Of HCF of 32, 216, 136, 88, 184 and 120, and all of this is going to be what? 8. Now the minimum number of boxes is going to be what? 32 plus 216 plus 136 plus 88 plus 184 plus 120 divided by what? Divided by 8. And this number is going to be what? 97. Hence the answer is that there has to be what? 97 boxes. So I hope you people have understood little bit about HCF and LCM. You can go to EduRev and attempt these tests to understand this chapter in depth. You can unlock all the logged videos, documents and tests for CAT with EduRev Infinity Plan and ace your exams at less than 80 rupees per month. Thank you.